Alrighty, this is going to be part 2 of today's lesson on representing quadratic equations with graphs. What I'm going to do is number 5. Okay, we have y is equal to negative x minus 1 squared plus 1, and we want to graph this. We want to put this in standard form, and we want to put this in factored form. What I'm going to do first is go ahead and graph this. Notice how it gives you vertex form. So you have your vertex at positive 1, positive 1. You'll also notice that here that you have a negative leading coefficient, so your parabola is going to be side and it opens down. Now what we need to do also is figure out what my factored form is so that I can graph it. Meaning that I can't really do the graph for number 5 just yet until I get factored form. So in order to get factored form, I need standard form. So here, this is where we actually have to go from vertex to standard. I am going to do x minus 1 squared. That's going to give me x squared minus 2x plus 1. Now don't forget about my negative. And don't forget about the plus 1. So here's my plus 1, and here's my negative. If I simplify my negative, I'm going to get negative x squared plus 2x minus 1. Don't forget about the plus 1 again. And if I simplify that, I am going to get y is equal to negative x squared plus 2x plus 0, of course, because negative 1 plus 1 is 0. This tells me that negative x squared plus 2x is going to be my standard form, which tells me that my y-intercept is going to be 0, 0, because I don't have a constant value. We're going to see that kind of makes sense because on the next column, where we want to factor this, we are going to factor out negative x squared plus 2x by taking out a GCF. If I take out a GCF, I'm going to take out, let's say, negative x, so that I have x minus 2 right here. I'm going to set this equal to 0, and I'm going to set this equal to 0. Well, if negative x is equal to 0, then x is just 0. And if x minus 2 is equal to 0, then x is equal to 2. This means that I have roots or solutions or zeros at 0, 0 and 2, 0, which means I could put that on my graph now where I have 0, 0 and 2, 0. Once I do that, I could finally graph this and say that, hey, my parabola looks like this. It opens down and I have x-intercepts at 0, 0 and 2, 0. Remember that it opens down because my parabola is sad right here. It has a negative leading coefficient. Boo, it's sad. There we go. It's sad. All right. I'm also going to do number 6 with you guys, meaning that I want you guys to do 4 with your groups on your own. For this one right here. Now, we have vertex. This tells me that my vertex is at negative 4, negative 8, so I'm going to go ahead and jot that down. Vertex being negative 4, negative 8, because I'm going left 4, down 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is left 4, down 8. We also know that based off of this parabola right here, because I have a positive leading coefficient, my parabola is going to open up. The thing is, I don't know how. I just know that it's going to open up. Okay, now remember that I can't really graph this until I figure out my roots, my solutions, my x-intercepts. To do that, remember that my middleman standard form needs to be done. So here I am going to go ahead and multiply out x plus 4 squared Once I do that, I am going to multiply by 2. So if I multiply x plus 4 and x plus 4, I get x squared plus 8x plus 16. Okay. Now don't forget, I have this times 2, and I have this minus 8. So I need a minus 8, and I need a times 2. Make sure that you guys are using PEMDAS. So we are doing 2x squared plus 16x plus 32 minus 8. Simplify everything now. So 2x squared plus 16x plus 24. And that's going to give me my standard form for this problem right here. Well, to get factored form, we are going to have to use the box method. Now remember, always check for a GCF. In this case, our GCF here is going to be 2. I can divide 2 here, I can divide 2 here, and I can divide by 2 here. So that's going to give me 2x squared plus 8x plus 12. And now remember, we got to think factors of 12. That's going to give us a positive 8. Okay. So factors of 12, that's going to give us a positive 8. So what two numbers will multiply to 12 and add to 8? That's going to be, let's say, 2 and 6. 2 times 6 is 12. 2 plus 6 is 8. Once I do that, I'm going to go ahead and box. Okay. So that's going to give me x squared, 12, 2x, 6x. The GCF of x squared and 6x is going to be x. The GCF of 2x and 12 is going to be 2. The GCF of x squared and 2x is also going to be x. And we also know that the GCF of 6x and 12 is going to be 6. So this tells me that I have my factored form of x plus 2, x plus 6. And don't forget about your original GCF of 2 right here. Okay, so what does this tell us? This tells us that my factored form is y is equal to 2 times x plus 2, x plus 6. And this also tells us that if we set this equal to 0, we're going to get negative 2. And we set this equal to 0, we're going to get negative 6. Which means that my solutions, or my zeros, or my roots, are going to be negative 2, 0, and negative 6, 0. So I have negative 2, 0, and negative 6, 0. 2, 3, 4, 5, 6. Once you do that, I am going to go ahead and graph it. Doesn't need to be pretty, but as long as it looks like a parabola and it passes through the x-intercepts that we give you and the vertex that we give you, I will be fine. We are going to be okay. I promise. So notice how here, my vertex is at negative 4, negative 8. And this tells me that I have my roots at negative 2 and negative 6. The only thing that we couldn't do really is the y-intercept here, just because y-intercept is kind of too big for us. It's 24. Now, like I said, I want you guys to do number 4 in terms of this right here. So when given your vertex form, go from graph vertex to standard, and then standard to factored. And then once you do all of that, graph it. Today's Delta Math is going to be parabolas, intercept form coefficients. And today, this lesson is actually the last lesson before you guys take your test on Friday the 5th. Meaning that you should be prepared. Tomorrow, Thursday, 4/4 is going to be your test review. So you guys can do that on Thursday. So by Friday, we should be comfortable with everything. And just like I said in that last video, your test here is going to be more FRQ, so you won't see a lot of multiple choice. So like I said, be prepared to, if I give you something like this, be prepared to show your work going from vertex to standard and standard to factored and then graphing it. So this would be like a very good FRQ problem in terms of your test on Friday. All right, that being said, I will be back home on Monday the 8th, and we will start Unit 5 then.